properties of lightning. An average volt of lightning carries an electric current of 40 kiloamperes and transfers about 5 coulombs of energy. This, comparatively, if a large bolt of lightning comes, it has about 120 kiloamperes of energy. This, the dielectric breakdown of air being a 3 trillion volts per meter. That is, what is the dielectric breakdown is? Air is an insulating material. When the electrons are present in the cloud and if the positons are present in the ground surface, actually we know the soil contains negative and positive particles. But when the cloud, which has a lot of electrons below, it attracts all the positive particles from the ground and it accumulates at a particular point. And this electrons will attract this positive. And when this transition takes place, the Earth is an insulating material, but it has a resistance. It has a resistance of about 3 million volts per meter. If it crosses that, if the electrons crosses that insulating capacity, the potential of the air, then the dielectric breakdown occurs. That is a path of lightning. So the lightning gives us the air about 10,000 degrees Celsius. Generally, we know that on the surface of the sun, the temperature is about 6,000 degrees Celsius. But the lightning is much more than the surface temperature of the sun. The lightning forms a nitrogen oxide in the atmosphere. Due to lightning, a lot of environmental impact also takes place. There is the nitrogen oxide in the atmosphere also comes. Greenhouse gases also increase due to the effect of lightning. The plasma formation. Plasma formation is nothing but the ionization of gas. During lightning, a lot of gas is present. While this bar, a lot of gas is ionized. And due to that, high levels of oxygen, nitrogen, OH, and NO are all formed. So this ancient research. First of all, we know that in 1752, Benjamin Franklin, he made an experiment, a simple experiment that he made a kite and he tied a key at one end of the kite. And while lightning came, he passed through the kite and it came near the key. He showed some of the sparks. That I told before that due to the electrostatic discharge of this electron, there is a dielectric breakdown. Due to that, this spark comes in the key, and due to this, in the string also, some of the fibers which are going away, it comes and straightens as a string like that. So just we know that if we rub on our hands with some piece of cloth, our hair will stand up. It's like a good flush. So this is a garden bell. Here, lightning rod, this is a lightning rod, this is connected to one bell, and this another bell is connected to the ground. So when lightning occurs, this one is fully charged with electrons, and this attracts the ball which has some positons on it. So if this ball goes away, and it is fully charged with electrons, and this is attracted by the other ball, then it transfers the charges from this to this bell. So this is a Gaussian bell. This simply shows how the electrons are transferred from the side to the ground. So formation of lightning. There is charge separation, needle formation, discharge, and discharge. This charge separation is nothing but I explained before itself. During the wind, lot of electrons and particles are formed in the sky, and the less denser particles which come below carry most of the electrons, and some of the positons which are present goes above the sky itself. And after that, there will be accumulation of lot of electrons, and there will be a huge amount of electrons that it forms a path. It attracts all the positons which are present in the ground, and it attracts all the electrons from to the positons. So it a dielectric breakdown forms, and this leader is nothing but here the path which goes below. This is the lightning strike. So this is how the lightning forms. The second figure shows the return flow. That is, after lightning, the path is already formed. So again, in the same path, later some lightning can occur. That is called as dark leader. That is nothing but the effect of first lightning will be much more than the other lightning. This is how the lightning forms. here the positive charge particles is represented from in the sky. A lot of negative charge particles are there. So this negative electron will attract the positive electrons, and this is how lightning is formed. So occurrence of lightning. Generally the lightning occurs close to ground, which is most evacuum, and the intra-cloud and inter-cloud. This is how it occurs. Intra-cloud is nothing but the same cloud I told before, the electrons are present in bottom and the positons are present above. So in between the same cloud, if both join, so it forms an intra-cloud lightning. In inter-cloud, between two clouds, the transfer of electrons takes place, then it forms inter-cloud. And close to ground, there is nothing but the ground surface as positons, which I have explained already. This inter-cloud is very rare. This inter-cloud is very rare. The intra-cloud is most commonly happening thing, and the close to ground is occurs rarely, but because of the devastating effect. This is some of the types of lightning. That is fork lightning. The background is picture shows how the fork lightning occurs. The lightning stroke is branched and usually from a zigzag pattern, and the lightning mostly travels from cloud to cloud between the clouds. And rarely the effect is formed stream lightning is similar to fork lightning, but it follows the same zigzag pattern, but it doesn't have any branches. So the average number of thunderstorms in a year. Here you see in Cochin and Kerala areas a lot of lightning occurs, and here Assam and here Ooty also a lot of lightning occurs in southern part, and similarly in northeastern region also a lot of lightning occurs. Depending upon the IITD, if it is number of days is less than 10, very low hazard, 10 to 30 to 50 moderate hazard, 3 to 8 high hazard, and very high hazard. So time taken between lightning and if we divide by 5, we will give how far from us this lightning occurs.
How far in terms of
kilometers? Kilometers. Oh, miles.
Complete presentation. What it is during production and then development. I think okay. Can we go for another one? Before? No? Huh? Related to Ganga. India has become the capital of the country. Population has increased and obviously no more than vegetables is full of did you fill up this form? Into the condition of the river and the view. Anybody into the condition of the river and into the evaluation condition of the people who are living better of the river. The NIH standard this is about NIH. It was implemented in 1993 with the aim of pollution abatement and water quality improvement of river system by NRV, National River and the Ministry of National River Conservation Directorate and Ministry of Environment and Forest. Our Indian government has taken the look of the Japanese government. Japanese government has given a financial aid of 17.7 billion Japanese yen. Under this NIH plan, 15 platform firms are coming. 6 from Haryana, 8 from UP, and Delhi is also coming. 6 more town for